Hello, my name is Michael Sullivan, author of Statistics Informed Decisions Using Data. First, I want to thank you for your interest in the fifth edition of this text. As you are well aware, choosing a textbook is one of the most important decisions we can make as professors. It is important that we choose a text that contains clear, concise, and accurate explanations along with plenty of examples. The exercises need to build students' confidence in the material, yet challenge them into thinking statistically. I can assure you, with over 2,300 exercises in the text, there is no shortage of material to assist your students in developing their ability to create and consume statistics, as well as learn to think statistically. Now, I would like to highlight some of the features that appear in the text. First, we offer side-by-side presentation of by hand and technology solutions, recognizing that there are different philosophies regarding the use of technology in the introductory statistics class. Consider, for example, on page 486, example 2, where we're testing hypotheses about a population proportion using a two-tailed test. You can see that we go through the steps, and at step 3, the two approaches, classical and p-value approach, are presented side by side. In addition, with the p-value approach, we give you both a by-hand approach to solving the problem as well as a technology solution. The textbook contains technology step-by-step that appears at the beginning of each end of section exercises. So here is technology step-by-step for the TI-83, Minitab, Excel, and StatCrunch. We also offer what are called putting it together sections. I encourage you to look at the front inside cover of the textbook, where we list out the different putting it together sections that exist. I got the idea of putting it together sections when I discovered that students are good at doing inference when they know the type of inference to conduct. For example, when a student is in section 11.1 on inference regarding two independent population proportions, then he or she knows to conduct that particular type of test. But when it came time to take the test, my students had a difficult time deciding which inferential method to use. This led to the putting it together sections. For example, if you look in section 11.5, I have a putting it together section. The section has a flow chart which allows the student to follow logical questions to ask in order to assess the type of inferential technique to use. And then there are a mixture of various types of inferential techniques studied up to that point. So not only including problems from chapter 11, but also problems from chapters 9 and 10. 9 is confidence intervals on a single parameter, and 10 is hypothesis testing on a single parameter. I would encourage you to look at problems 23 to 29 in section 10.5, or here in section 11.5, problems 24 to 33. These are particularly interesting because they require the student to explain which inferential method should be used based on the research objective. There's an online homework delivery system, plus a whole lot more, entitled My Stat Lab. So it's not only an online homework delivery system, but contains other ancillaries for your students. For this particular edition, I went through and did a complete edit of all the My Stat Lab problems and made requests for new problems. Now, the problems in My Stat Lab reflect the depth of the problems in the text. Students also asked for more technology help. And so if you look in my Stat Lab, I'm just going to go to the study plan, and I'm going to go ahead and open up homework problems from chapter 4, section 2. What you'll notice is there are -T problems that exist. The -T problems refer to technology problems, and these are the problems that have the technology help. So if I click this problem here, you can get a preview of the question from the student's point of view. And over on the right is the list of various learning aids. If the student clicks question help, you can see there's a tech help listed there. If the student clicks tech help, the student gets technology step-by-step for the TI-83, 84 Plus, StatCrunch, and Excel. Also with this edition, we updated all the videos. Every example from the text has up to 3 different approaches to the solution taken: by hand, using a TI graphing calculator, or using StatCrunch. So again, if I go to Chapter 4, Section 2, and check video, you can see that here in Chapter 4, Example 1, there's a by hand, a StatCrunch, and a TI video for the student. In addition, videos include many of my actual classroom lectures that develop concepts. Finally, in the chapter test, each problem has a video solution. This is a great resource for students who need help when the instructor is not available. A big trend in introductory statistics class is to introduce inferential methods using simulation and randomization techniques. Under Tools for Success, we have a student activity workbook that addresses this need. There are numerous problems and activity that utilize techniques for hypothesis testing on proportions, hypothesis test for 2 independent proportions, hypothesis test for 2 independent means, and hypothesis test on correlation. So if I go, for example, to Chapter 10, here is an example of an activity that uses an applet that introduces the student to the logic of hypothesis testing. If I go to Chapter 11, in Section 11.1, here's an activity that introduces the students to hypothesis tests on 2 proportions using randomization techniques along with an applet. Specific activities are suggested with annotations to the instructor in the text. As I indicated earlier, there are over 2,000 exercises to choose from the text. The exercises have been developed to allow students to develop skills, but also to challenge students to think statistically. In addition, the data sets and studies in the exercises were chosen so that they appeal to today's students. Let me give you a description of some of the various problem types. First off, we have what are called putting it together problems. These require a student to utilize skills learned in previous chapters so he or she can see how the various skills relate to the material in the current section. On the front inside cover of the text, there is a list of all the putting it together exercises along with the skills utilized. One of the things that's changing in the introductory statistics area is the idea of using larger data sets. With the omnipresence of data and the ability to extract large data sets from the web, the introductory course exposes students to large data sets. These problems are marked with a special icon in the text. The icon can be seen here, and you look at problems 25 and 26, you can see that we use a bigger icon to indicate that there's a big data set. The student is expected to go to www.pearsonhighered.com/SullivanStats and download those particular data sets. New to this edition is something called Retain Your Knowledge problems. We all know that students tend to forget content that they don't use. To help students keep information fresh in their minds, I include Retain Your Knowledge problems. These problems are meant to assist students in retaining skills learned earlier in the course so that the material is fresh for the final exam. The following are some examples of Retain Your Knowledge. In Section 10.3, look at problem 36. This is a problem that asks students to remember information from Chapter 1, where we introduced the idea of data collection and design of experiments, along with observational studies. If you look at Chapter 11, Section 11.3, Problem 24 is not only a big data problem, it's also a Retain Your Knowledge problem that deals with scatter diagrams, correlation, and regression. And so you can see, even though we're in Chapter 11, we're reminding students of skills learned way back in Chapter 4. This helps to ensure that they are prepared for the final exam. The American Statistical Association continues to encourage instructors to develop conceptual understanding. A concerted effort was made to expand interesting data and research that allows students to see the power of statistics and develop conceptual understanding. I ask you to look in section 4.1, problems 33, 34, 37, 38, or 39, or in section 9.1, problems 48, 52, or 54. In addition, problems are included that require students to develop studies that utilize the inferential techniques studied within the section. For example, look in section 11.1, problem 35, or in section 11.3, problems 25 and 26, or in section 12.2, problems 19 and 20. Students have a difficult time understanding how to determine the appropriate data analysis tool. To assist in this process, I have written problems that ask students to determine the data collection technique and types of variables in the study, quantitative versus qualitative, for example. The idea is that students will recognize the type of analysis that applies to qualitative data versus quantitative data. For example, in section 11.3, problem 8, we're comparing two independent means. I ask students to identify the type of experimental design, what the response variable is, what the explanatory variable is. I'm trying to get students to understand what inferential techniques apply to different types of studies and different type of response variables. Lastly, under instructor resources, we offer an instructor resource guide. The instructor resource guide provides an overview of the chapter, details points to emphasize within the chapter, and provides examples different from those in the text that may be used in the classroom. So here's an example from chapter 7 where we give an overview of the chapter and then additional classroom examples that you can use in class to illustrate various concepts presented within the section. These are just some of the many features that I've included in the text in order to facilitate student learning and motivation. Should you have any questions at all, please contact me via email at sullystats@gmail.com. I look forward to hearing from you, and thank you again for considering my text.